In this video we are going to deal with a previous gate problem given in 1998. So, this is related to Z transform. The Z transform of the time function summation k is equivalent to 0 to infinity del of n minus k years. So, this is a impulse train from 0 to infinity. We need to derive the Z transform for this impulse train. So, the options are given like z minus 1 by 2, z by z minus 1 and z by z minus 1 whole square, and option D is z minus 1 whole square divided by z. So, all these options are given, that is okay, but what we need to find out, this is a time function. In Z transform equation also you are having summation, in given signal also you are having summation, no need to confuse. So, here first I am drawing my given signal is summation k is equivalent to 0 to infinity del of n minus k. So, when k is equivalent to 0, so that is equivalent to del of n. When k is equivalent to 1, that is equivalent to del of n minus 1. When k is equivalent to 0, this is equivalent to del of n. When k is equivalent to 1, that is equivalent to del of, so here 0 to infinity means del of n minus 1. K is equivalent to 2 means del of n minus 2. So on. So, here what is the del of n value? So, at n is equivalent to 1 you are having sample. What is the structure of del of n minus 1? So, if this is n is equivalent to 0, at n is equivalent to 1 you will have value. So, like that del of n minus 2 you are having sample at 2. What we are doing here in this signal, we are summating all this del of 0, del of 1, del of 2. So, this is del of 0. So, when k is equivalent to 0, that is del of n. Del of n minus 1 means shifted del of n. N minus 2 is also shifted del of n. So, we are combining in this summation. So, that means from 0 to infinity, summation del of n minus k is nothing but del of 0 plus del of 1 plus del of 2, so on up to del of infinity. That means not del of 0 actually. So, this is equivalent to del of n, del of n minus 1 plus del of n minus 2, like this, plus so on. We know the structure of is every del function. That means, so at 1 you are having sample for a del of n minus 1, at 2 you are having sample for a del of n minus 2. If you are adding all this, then the resultant signal will be like this. From 0 onwards you are having samples. By adding each and every del function you are going to get like this, n equivalent to 0, 1, 2, 3, 4, so on up to infinity you are having sample equivalent to 1. This is nothing but u of n. So, indirectly they are asking what is the Z transform of u of n. What is the Z transform of summation k is equivalent to 0 to infinity del of n minus k means do not confuse. Just draw the structure of that signal and you will get So, that is equivalent to u of n. So, this is u of n. For this signal, this is nothing but u of n. For this u of n, what is the Z transform means? We already derived Z transform of u of n as z by z minus 1. Once again, I am going to derive that summation n equivalent to minus infinity to infinity. In place of signal, I am substituting u of n, z power minus n. This is Z transform equation. In place of x of n, I substituted u of n. When unit step function is there in the summation, so you need to write 0 to infinity z power minus n. So, this is equivalent, I am writing like this, n equivalent to 0 to infinity z inverse whole power n. So, this is nothing but 1 minus z inverse, 1 by 1 minus z inverse. So, which suits this answer means So, if you consider this Z inverse as 1 by Z and if you cross multiplied, so that is equivalent to Z by Z minus 1. So, this will be the right option for this problem. By observing this itself, do not confuse. So, you just draw the signal equivalent for that, and after drawing this signal, you will get an idea that is equivalent to unit step function. So, deriving Z transform for unit step function is very easy. You will get Z by Z minus 1. Please keep in mind the Z transform of unit step function is equivalent to Z by Z minus 1. That may be useful in so many problems. So, here itself, if you know what is the Z transform of unit step function, then you can go for that option. If you do not know as a fundamental signal, then you need to do this procedure. After that, you are going to get the same Z by Z minus 1 will be the Z transform of summation k equivalent to 0 to infinity del of n minus k, which is nothing but unit step function.